we're involved in defining, measuring and modeling performance of systems built with 5G or otherwise. Next slide, please. Okay, so I think it's interesting to ask what end users want, whether those are consumer end users or industrial end users. They care about their application performance. So the time between doing some sort of click and some sort of action, whether we're talking about a video game or whether we're talking about a teleoperated forklift truck. And obviously, if we're doing any kind of video delivery or concert streaming event, they're interested in the frame rate and all that. They're also interested in the consistency of that performance. It's in many cases not really very useful to deliver a fantastic performance under optimal conditions if an adequate performance can't be maintained under worst case conditions. So really, the question of the consistency of the performance, regardless of issues to do with the network, whether you want to sell edge, whether your SNR has been degraded and so forth, or the amount of traffic on the network, and indeed what other users may be doing. So that's really the kind of thing people do care about. What they don't care about, unfortunately, is 5G. Or bandwidth particularly, or latency, or any of the exciting technical things which we like to demonstrate, only insofar as those impact the things they do care about. So the question is how these are related. So what we have been doing over the last 15 years really is to develop a rigorous approach, a mathematically based approach to relate application performance to network performance. And we do this via a measure that we call quality attenuation, which for historical reasons we write delta Q. And this is a mathematically composable measure. I'm not going to go into the significance of that, but that is quite important for the things you can do with it. But from the point of view of projects, it delivers highly granular visibility about what's happening in the end-to-end network. And this is an approach which is currently in the process of being standardized in the Broadband Forum. We've used it in a wide range of contexts, from wireless mesh networks for the US military, to commercial network operators, both fixed and mobile, particularly helping them diagnose performance issues in their networks and with various kinds of applications. And we've also applied it at the kind of application level for distributed applications, for example, proof of stake blockchain systems. Okay, next slide, please. So the kinds of things we can do is to measure network performance in this advanced way, which enables us to localize where any issues may be arising. It gives a very precise and deep view of the effects of technology or configuration changes. We can also measure the application requirements in terms of this parameter. So we have an environment which enables us to emulate the quality attenuation of a network. And this is more robust really than having to emulate the whole network. We can just reproduce its impact in the way that it impacts applications, and we can do that repeatedly. So that provides a way of doing performance regression tests, for example, for application developers. We can also model system performance. I said we have a mathematically based approach, and this enables us to combine both synthetic models based on architecture and so forth with measurements taken of particular network segments or technologies, and we can model the effect of various edge cases and the effects of correlated loads and so forth to address these questions of how consistent and reliable the performance is going to be. So we're interested in projects that are aiming to deliver reliable application outcomes, to deliver assured services, and particularly anything to do with safety of life or business critical services. we have a lot to offer in terms of the assurance of that kind of delivery.